For this extra on this DVD, we're going to take a look at how we can update one of the scripts that we wrote. We wrote this script here that actually set up, I'll just evaluate it and then run the function, that set up the control object for the blended morph system. This set it up so that we actually had an object that wouldn't pass beyond the boundaries of the rectangle. We had to use custom attribute definition, and we had to play some tricks with list controllers to get it all to work so that it wouldn't go too far. Well, in actual reality, we don't need in Max 8 any of this area at all. Basically, this is all the area that we created the custom attribute definition and connected things together. Now, this worked really well and was a great way to get around things, but it simply isn't needed anymore because we have what is called the limit controller. What I'm going to do is I'm just going to take this object here and just delete it and just rebuild a circle so it's clean. It doesn't have anything extra in it. And I'll show it to you first about what we're going to be doing. So we would have this sort of set up, and it passes out the outside of it. What we can do is we'll just take the X to start with. I want to say assign controller and say float limit. And the float limit dialog box comes up that now controls the object and allows us to be able to put in a limit value, high and low. Well, it's pretty easy. What we're dealing with right now is the X values, that's side to side, and our width of our box is currently 10, so that all we need to do is just simply put in 5 and 5 for half of it. And I guess we should have -5, sorry. -5. So that what it does, it stops it when it gets to the sides. Same thing happens to the Y value. We just need to stop it at 5 and -5. So there's the limit controller, and that is much, much easier to set up, obviously, than the system that we had to use. I'm just going to delete all this, and we're going to set it up from scratch. The float limit controller, it only works on float values. So I'm just going to give it a variable of FL, and it is called float limit. And if I evaluate that, it'll actually give us a float limit controller. And if I say show FL, it will show us the parameters that we can set in it. Because what we're going to do is we're going to wire the high and low values to the actual length and width of the box. So it reacts just the same as it did when we set it up with the script controller, that the length and width parameters of the box determine the actual value that it stops at. What we're going to do then is we're going to take the controller for the x-axis and apply this to it. So our control object is the actual circle, which was being called circle. And we're going to say circle dot position dot controller. And we're going to look at the first one in that controller. So let's actually just run some of this code inside so we can see it work as we go. So I'll run all that, and it actually creates the control object and rotates it up to face the front viewport. I'm going to create the float limit, and then let's apply it to the X position. So first one in this controller is the X. We could have also said .x_position, whatever you returned it as well. 1 will get us there faster, knowing that it's the first one. .controller, if I can spell it correctly, is the actual Bezier float controller. And what we need to do is we actually need to make it the float limit controller. So now that we have the float limit controller on it, you can see it's actually applied the float limit controller to the X position of the circle. So we've applied the float limit controller, and then the next thing we need to do to actually limit it is work with the values. Now, as we saw here, we can use the upper limit we'll start with. We'll say FL dot upper limit equals 5. You can see that it stops when it hits the side now at a value of 5 in the x-axis. What we want to be able to do is we want to be able to connect this with the param wire connection up to the width of the box. So what we're actually looking for is another way of getting at this upper limit, and what we need to do is we actually need to say FL dot limits, because this is the we need to there's the controller dot limits, and then we need to list the upper limit as the name of it. So limits, and that will return the upper limit as well. And this is how it's required for the param wire dot connect. So now the next thing we need is to actually do that connection. Param wire dot connect. The first one that we have to list is going to be the driver in this case, so that'll be the width of the actual rectangle. The rectangle is called REC, so rec dot base object will return the very base object, and that's how you have to do it to be able to get at to be able to get at the width as a string again. So then we need width. So if I evaluate just this line, it should give us the width, the subatom width track, and then we need to write the expression. Now the expression is going to be very simple, because what we need is we need half of the width in this case. So it's passed as a string, and we need to say width divided by 2. And now you can see that it actually hits the edge now. And there's a wire parameter on here with that expression written into it. Exactly the same thing needs to happen for the negative, so that it stops at the negative, and this will be the lower limit, and we're going to say width divided by 2, but we actually have to say negative width divided by 2. So we'll connect that one up, and now that stops the other side. Now we simply need to do the top and bottom as well. So what we can do here is we can cut and paste this entire piece of code. We want to start with the new instance of the float limit controller. It'll be on the y-axis this time, so it's this second track down, so that'll be number 2. And we apply it, and you can see that it's now applied to it. Exactly the same things here, except instead of width, it's going to be connected to the length. We need to change that in the expression as well. And that should be it. If I run it, we now have connections on it. And for some reason the wire parameters aren't showing up. Oops, because I ran the whole thing again. It looks like we put it on twice. Better actually just redo that just to make sure, because I actually ran and added the float again. You don't want to do that. That would be adds 2 of them, basically nest them one inside each other. I'm just going to say assign controller. There we are, back to the basics. Run that again. There we go. So now it locks it off, and you can see on the first one there's our wire parameters icon in there. So that is blocked it off. Now one of the hassles, and it seems to be in Max 8 still, is that if you lock off the Z-axis and position and you're in local mode, you can't grab this part of the icon. This is something I explained in the first part of the DVD when we were working on the blended morph system. It seems to be a little bit of a bug in this, that you can't grab it. So the workaround to that is to not set the flags to lock everything off. So don't set the transform flags for the position at all. Do it from 4 to 9 with the bit array, because that'll do the rotations in scale. 1, 2, 3 in here is actually the positions. So what I'm going to do is I'm just going to go back and unlock the Z. Now we can move it here. So to get around it, and just to get around that little bit of annoyance, what I'm going to do is I'm going to set this also on the Y or the Z as well. So I'm going to go in and set up the same limit on here. But instead of wiring it to anything, because it really doesn't need to be wired to anything, I'm going to simply delete all of the wire parameter information. And I want to take the value of the upper limit and make it 0. So now it's got a limit on it, and the limits are set to 0. So if we actually take a look at the limits here, they've been, whoops, again, I went and did it again. I doubled it up again. So let's just set it back, run that whole thing. There we go. The limits on these have been set to 0 now. So you can see the value's been set to 0. So now you actually can't move it back and forth, even though you can grab that Z axis, but now you can actually grab the icon properly for X, Y. Strangely enough, that's tends to be the best little workaround for it. I've included the script and the control object so you can rip apart how this is done and how it's set up. In this Max 8 Extras, we're going to look at two new tools. One is the new script controller and how that functions, as well as a new tool that was added in Max 7 that I may not have covered because the initial 3 DVDs were done in Max 6, is the Expose Transform Helper. So what we're going to do is basic stretchy leg setup again. And we're going to start with typical leg. I'm just going to use a sphere control of mine just for the bottom of the leg here. And I'm just going to align it. And we're going to apply a point helper to the end of the leg. We're going to need to help get the distance, or else we'll get circular dependencies. I tend to do this anyways. I always tend to add in, essentially use my grouping function to throw in a point helper at the end of the leg, and so that the leg is now just parented to it and it's aligned up to it. From the thigh bone down to the ankle, I'm going to place a high solver. Just reduce the size of the goal. And I'm going to parent that up to our control object. And let's just go ahead and animate this a little bit so we can see it working. And then I'm going to stretch it down too far, take it down below the ground. So got a little bit of animation on it as it goes up and down. Now what we're going to do is we're going to use an Expose Transform Helper, which is under the helpers, Expose TM. And this Expose TM helper, you can see, has a whole lot of parameters to it that are currently blank. It's because what it's designed to do is actually expose data about objects for their transforms. So I'm just going to turn on axis tripod so we know. I usually throw that on for the Expose TM helpers. And what we're going to do is we're going to use this to get the distance between the top of the leg and the control object. Now we could do that in script again and we could find that distance, but this is just one example of how to use this. The exposed node, I'm going to pick as the top. It automatically picks the parent node for you, and since there's no parent to this, it's picking the world, and it's giving you the distance between this and the world. What we're going to do is we're going to say pick the parent, and it's going to be the ground sphere, and so there's the actual distance. What I'm going to do is I'm going to pin the stack here so we can keep looking at the expose transform, and you can see the numbers changing. One is the local position, as well as world position, the local angles between them, and the world angles, distance, and the angle between the objects. So we can get a whole bunch of information from the expose transform helper to be able to help drive things. It's also very quick doing it this way. Instead of trying to extract angles out of joints using expressions or using script controllers, the Expose TM will do it quickly, and we just need to connect or wire even just up to these parameters that have been exposed now. In our case, we're going to use a script controller and show you how to use the new script controller that is name independent, where we can add variables just like you do in an expression controller. To stretch this leg, we're going to move it along like we did in previous examples. We're going to move it along the local x-axis, and of course the N1 the nub bone to stretch this joint, we're going to move it along that axis as well. So I'm going to grab both of those joints, and I'm just going to use the built-in freeze transform tool, which will put list controllers on them and freeze them to have the 0 value in the second controller. I want to start with the first one here. I'm going to open up a graph editor just to work with. I'm just going to hide off the key window and set it to selected objects so that we have a way to basically get access to the controllers. So we're going to start with the frozen X position of this, and we're going to add float script controller to that track on the calf bone here. Now you'll notice that the script controllers in Max 8 look a little bit different. They look very much like the expression controllers do in previous versions of Max. The advantage now being is we can create variables. Those variables can be tied directly to a number of different things. Constant values, an actual track, a controller, or an actual node. And we can reference them. The advantage here is that one, it's going to make the script controllers much faster, and we no longer need to have depends on statements at the top of them. And also, we don't have to use tricks that I've done in the past, which is adding custom attribute definitions to the script controllers to try and store this data for us. What we can do now is we can just store the references to the tracks or the nodes that we need, and then use those in the expressions. This makes the script controllers much, much faster because they don't have to search the scene for the node anymore. So let's go ahead and do that. We're going to start with one, and we're going to call it dist, and say create. Now we need to assign it. Now we know that the exposed TM helper is actually giving us the distance. So what we want to do is we want to connect it up to this track of animation here. So we can say assign track. Let's expose all. There's the exposed TM. There's all the parameters we can expose, and there's the distance. So then now that we've got the distance, we can let's just do a test here, and let's say print dist. And I'll just open up the, and you can see that when I hit evaluate, I'll just move this, make this a bit smaller so we can see it. It's evaluating the current distance between the top point helper we chose and the control object. And if I scrub the animation, you can see that distance changing. We really need to get a 0 value because we zeroed this node here out, and we want to be able to know what that 0, we want to be able to get the distance back to 0. So what we're going to do is we're going to start with the current default value of the distance. So we can get it from one of two places, from the listener right now, or we can just copy and paste it from the exposed TM helper. Just so you know as well, if you hit the M and do a paste, you'll actually get the command to be able to get it through script for that track. We need just the value at this point. And what we're going to do is we're going to make a constant value. I'm just going to call it const, create. We're going to assign it a constant value this time. And that's going to be the initial starting point for the leg. So now if I actually say minus const, you can see that it's near printing 0. Max has a problem with rounding, and we'll often have very, very small numbers sometimes. You can see that's giving us essentially a value of 0 to start with. Now what we need to do is we need to just work out an if statement to be able to work around this. So now we've got these very specific values. The next thing we might want to get is the actual point at which the knee goes straight. We want it to start stretching. And let's just turn on animate and see if we can find that point at which we want it to start stretching. Let's say just leave a touch of a bend in it. That'll be a very, very small value now. So it's near 0. It's just slightly over it. So what I'm going to say is call this the straight value. So we're going to call, say, create. And again, we can assign a constant to it. And so we should have all of our math now to be able to work out and get the stretch happening correctly. Now we need to do is need to check and see if dist minus constant is over that straight value. So we're going to say if dist minus constant is greater than straight value, then, and we'll throw the else statement in right away. Still have 0 down here so that when we testing our code, it'll always just return 0 at this point and not do anything. In here now, what we can do is put the stretch amount that's going to happen, and in the else we can say 0. So essentially when it's getting shorter, we don't want to stretch it. We just want to leave it at its current value. When it's getting longer, we want to be able to do something. And now what that's going to be is we're going to take the value. So let's actually get rid of our 0 now and see what happens. And you can see that it's stretching. Now it's stretching far too much at this point. And you can see it's stretching all the way down. What we need to do now is we need to sort out divide by 2. We have to divide it in half because we're going to be spreading the load between this joint and this one. So I'm going to say evaluate. And you can see that it spreads, it's now only going halfway. Just to get this working on both of them now, I'm going to take the controller off of this one, say copy, go down to the nub bone on the end, it's on the same track, I'm going to say paste instance, and let's play it back and see what happens. Now see, the problem is that the leg gets that point and starts to stretch out. So what we want to do is we actually want to subtract straight value out of it, and you can see it goes to that near straight point now where we asked to go to. So this point, as it gets longer, it starts to straighten out. Now we could even go down to the straight value that we've got assigned for a constant, and we could make this a bigger value. So let's try something like 0.41, and you'll see that the leg will get slightly straighter each time that we increase that value up. Say evaluate here. And you can see the leg's almost getting straighter and straighter. So you can sit there and play with that and get it to the point at which you want it to be at. And now it's actually going straight. And we don't quite want it completely straight. So let's try a value of 0.55. And you can see it pop back out again. So there's our setup using expose helper. Let's actually take a look at using expose helper as well for doing another setup with a stretchy bone. It's essentially the same thing, but we're going to use the expose transform to expose the angle of this knee. Same thing this time. However, I'm not going to pick a parent. I'm just going to pick this knee joint. You can see that it's returning a local value here, and the current angle of this knee joint is -17. And you can see that the angle changes as I scrub it back and forth. And so what we want to do is exactly the same sort of routine. We want to be able to drive, let's say, a stretchy bone with this. So what I'll do is I'll just go and make a quick stretchy bone setup. Put my bones in there. I'm just going to run my stretchy bone setup. And you can see what it's done is it's actually created the point helpers and set up all the constraints for a stretchy bone setup, which I'm not going to show you here because it's something we've covered in multiple different places throughout the DVDs. I'm then going to freeze the transforms on both those so that they are frozen and have 0 values that we can start with. And then on the X value of this one, we're going to go and do the same thing. We're going to go in and put in a script controller again, float script. We're going to call this knee angle for our first variable, and that one is going to be assigned to a track again, and that track is going to be this expose TM helper, which is down here, and we're looking for the, I believe, the local Z-axis. So we want that local Z-axis here. and that is now assigned that, so we can actually get that angle back out. So print knee angle will give us the knee angle. And again, we'd like to have a 0 value from that, so we need the default knee angle. And again, we could call it a constant value. And we'll just assign that a variable. Again, we could actually put this in right in here, but these ones are great to work with. So if I put minus const again, we should be getting a near 0 value. Again, this is an exponent, so it's right on 0 essentially. And now what we're able to do is able to drive the position of this with it. So I'm just going to get rid of this, say evaluate, and now you can see it's driving it. Now it's driving it way too fast, and it's driving it in the wrong direction. So we can easily just invert that value, and I believe that should do it, and it goes firing down, so we actually don't want to do it that way. We want to invert the whole expression, so outside of the brackets. And now it's going too far in the other direction, and we just need to find a multiplier. I'll just find something that looks like pretty low I'm going to need. And there you go. So now you've got a stretchy bone reacting, and we can determine with that multiplier. Now we can even create a multiplier here, or we could actually set it up so that there's something on screen that sets up that multiplier. And again, we just add it as a constant and multiply it by it. So now we've got a stretchy knee set up, a thigh bone set up that's stretching out. And it looks to me like it's going way too far. And we can then stretch it along that axis. So again, we just need to set the bone as a stretchy bone here, and we've got a setup with a stretchy thigh bone set up. And we can make it squash and stretch, and there we've got a squash and stretch bone working on a thigh bone using Expose TM helpers and the new script controllers. Again, all of this is name independent. You really can't break it. We can actually take it and rename objects to the same base name. So now everything's actually named the same in the scene, and everything still functions and works as it should because nothing is name dependent, and it's all very quick. These Expose TM helpers can just be parented into the root of the rig somewhere. I usually parent them into places around the rig that they should sort of stay with and just place them off to the side. But I use these all the time for driving all kinds of things in rigs now because they're so quick and easy to use. Well, there's my demonstration of some of the Max 8 features. I hope they're useful to you.